Hello everyone and welcome to this session on Introduction to Queues. I'm excited to guide you through this fundamental concept in data structure. Whether you are a beginner or looking to strengthen your foundation, this presentation will provide a clear and simple understanding of queues. In today's video, first we will understand what a queue is. Then we will explore the basic operations like Enqueue and Dequeue. Then we will learn about different types of queues. After that, we will dive into real-world application of queues. Finally, we will implement queues in Python. By the end of this video, you will have a strong understanding of queues and their practical uses. Let's begin with the basics. What exactly is a queue? A queue is a linear data structure that follows the first in, first out principle. This means that the first element added to the queue is the first one to be removed. Think of it like standing in a line for a movie ticket. The person who joins the line first gets served first. A queue has two main points: the front, where elements are removed, the rear, where elements are added. This structure is widely used in programming for tasks that need to maintain order. Now let's connect this to real life. Queues are everywhere. For example, the line at a ticket counter, printer jobs waiting to be processed, handling calls in a customer service center. Even YouTube processes video in a queue to upload and display them. These real world examples help you understand how queues are applied in programming. Now, let's talk about the operations you can perform on a queue. Enqueue operation, adding an element to the rear of the queue. Dequeue operation, removing an element from the front of the queue. Peek operation, viewing the element at the front without removing it. Is empty operation, checking if the queue is empty. These operations are simple yet powerful, enabling queues to function efficiently in various scenarios. Let's start with the Enqueue operation. It simply adds an element to the rear of the queue. Imagine you are adding another person to the end of the ticket line. For example, if we have a queue 1, 2, 3 and we add 4, the queue becomes 1, 2, 3 and 4. In Python, you can perform this operation using the append method on a list. Next is the dequeue operation. This removes the element from the front of the queue. It's like the first person in the line getting their ticket and leaving. For example, if the queue is 1, 2, 3 and 4 and we remove the first element, it becomes 2, 3 and 4. In Python, we can use pop of 0 method to achieve this. Queues come in different types, each suited for specific task. First one is simple queue, the basic FIFO structure. Second one is circular queue. The last position connects back to the first, useful for optimizing memory. Third one is priority queue. Elements are processed based on priority, not just order. Fourth one is DQ, a double-ended queue that allows additions and removals from both ends. Understanding these types helps you choose the right queue for the job. In a circular queue, the last position is connected to the first. This design prevents wasted memory by reusing empty spaces at the front. It's like a conveyor belt that loops around. Circular queues are commonly used in buffering and task scheduling. A priority queue processes elements based on their priority rather than order. For instance, in a hospital, patients with critical conditions are treated before others. Priority queues are widely used in algorithms and real world applications like job scheduling. Queues are extremely versatile. Here are a few use cases. First one is task scheduling. In operating systems, queues manage processes efficiently. Second one is request handling. Web servers use queues to handle multiple client requests. Third one is graph traversal. Algorithms like BFS rely on queues. Fourth one is messaging apps. Background processing often uses queues to manage messages. These examples shows why queues are essential in programming. Let's now see how to implement queues in Python using list. The simplest approach but not the most efficient for large queues. Using collections.dequeue provides optimized operation for queues. Using queue.queue, ideal for multi-threading and advanced scenarios. We will use examples to demonstrate each approach. Here's how we can implement a queue using Python's list. First we initialize an empty list, then we append 1 to it, then we append 2 to it, and at the time the queue will contain 1 and 2. Then when we pop 0, which means the element at the index 0 will be popped and 1 will be popped. So the queue will contain 2. And finally, when we print queue, it will print 2. This code shows how to enqueue and dequeue elements. Before we wrap up, here are the key takeaways. Queues follow the FIFO principle. Basic operations include enqueue, dequeue, and peek. Types include symbol, circular, priority, and dequeue. Queues are used in scheduling, request handling, and more. Python offers multiple ways to implement queues efficiently. In next video, we will dive into queues problems in Python. You have learned the fundamentals of queues from their concepts to their types, use cases, and implementation in Python. Now it's time for you to practice. Try implementing a queue on your own and share your experience in the comments. Thank you for joining me in this session on queues. I hope you found it helpful and engaging. Don't forget to like, subscribe to CodeMaster, and hit the bell icon for updates on more such tutorials. See you in the next video. Happy coding.